Social media come with many drawbacks such as the use offensive or hate language to offend others. In this project, we work on training models to identify and distinguish between offensive language and regular language, following the CRISP framework and WCAG. And now I want to go into talking about business and data mining objectives of business understanding. And as a business objective, we think we should learn how to use Weka at first, which play an important role in our data mining project, and then we will learn something about Python, which will help us convert the files of our data mining. What is more, as data mining objective, firstly, we will convert the relevant files for data mining, for example, convert the CSV files to R files. Secondly, we want to add some attributes in our files, which is better for our data mining works. Thirdly, we will select the different filters such as J48, SMO for get better results. Finally, we will modify the files formats for improve the percentage of our data mining results.
For the data understanding phase, the first step was disregarded. The second step is describing the data given and familiarizing ourselves with it. After exploring the data, it was discovered that the tweet ID is the key attribute that was distributed in all files to connect the tweet with its level and label. For verifying the quality of the data, it was concluded that the data given cannot be used in its initial format and must be converted. There were also outliers, including special characters like quotation marks and commas.
For the preprocessing, we have removed irrelevant data such as emojis, numbers, users, characters, and stop words. In the following slide, we will show the Python code that we use for preprocessing.
The primary goal of data preparation is to consolidate and process CSV or TSV files into alpha files that WCAG can recognize, and then we convert the raw data into structured data that WCAG can support. As you can see, we use Python to write a program to convert CSV or TSV files into text files. Next, we add some attributes and other header information into the text file, and finally, we can just directly change the name text to alpha file and use the WCAG to deal with the training set. And following is our pictures shown. At the same time, we can do the same thing with the text files, except that the text set need to be merged. After completing the transformation of the basic form of the file, we begin to enter the specific processing phase of the data. In the steps of transformations, we use string-to-word vector to transform the string's attribute to a set of the numeric attributes, which is convenient for clustering operations later. At the feature of selecting and visualization steps, we use the inform game attribute eval and ranker to get a rank of attributes sorted by relatively with classifier, and using the visualization tree to intuitively see if our classification is appropriate or not.
After the pre-process, modeling of the data was done by using different classifiers available under the Classify tab in the Weka Explorer. The test sets were also filtered and attributes were used to model the data. The attributes used were InfoGain attribute eval to model the subtask training set before using test sets to classify it, and different classifiers such as J48, 0R classifier, naive and SMO were used to classify and compare the results and to obtain the best result.
The parameter settings, we have used the default parameters. We have followed an iterative modeling approach as we started with the combined raw data to check the accuracy. Then we improved our data by preprocessing to enhance the modeling prediction. To evaluate, we have analyzed the following: accuracy, recall, and precision, which is found by the following equations. In this table, we contain the data we obtained from the equations. The following table contains the result of the classifiers we have run for modeling for subtask A, the classifiers we have run for subtask B, and the classifier we have run for subtask C. J48 is the most accurate one based on our analysis, as it gives a reasonable percentage for each subtask. Thank you for listening.